Hello there. We start off with the chapter Binomial Theorem, and this is the first class. So in this class we are going to talk about what is binomial expansion, and we are going to solve some problems on this. So to begin with, first we need to consider a binomial for a binomial expansion. So what is a binomial? Now, binomial is basically any algebraic expression with two distinct terms or two unlike terms, that is called a binomial. And obviously, none of the term is 0. So, in this case, let us consider a plus b. Now, a plus b to the power 0, or anything to the power 0 for the matter of fact, is 1. Now, a plus b to the power 1 gives you a plus b. A plus b whole square gives you a square plus 2ab plus b square. A plus b whole cube gives you a square plus 3a square b plus 3ab square plus b cube, and so on. So now, what if we want to find a plus b to the power n for any positive n, positive integer n, obviously? In that case, we need to understand that how these numbers, 3 here I have got a 2, so all these numbers are coming from, or how they come, we need to understand. Now obviously for a plus b whole square we already know how it comes. You just square it, rather you multiply it with itself, so that gives you this 2 somewhere. Same with this a plus b whole cube. But if we go for higher power, say randomly, if I want a plus b whole to the power 100, I don't know that how the numbers are going to come, because the idea of a plus b to the power 100 is I have to multiply a plus b 100 times. So that is impossible. So in that case, we need to arrive at some formula or somehow that we can understand how these numbers are coming. Now also there is another important thing that we need to notice. The thing is, if you see what is happening, it should be a cube. So it's starting with the highest power of the first term. Then slowly the highest power of the first term is reducing down to 0, and the second term is starting from 0 and going to its highest power till the last term. So it started with a cube, then it went a squared, then it went a, and finally a to the power 0, that is a is not there. And similarly in the first term b was not there, that is b to the power 0. Then it started with b squared, b cube. So what this gives us idea that in case of expanding any higher power of a binomial, the powers of the first term diminishes and power of the second term, it increases till the degree of the given binomial. So all these will be definitely based on how I get the coefficient, because once I know how I get the coefficient, that part is pretty simple to take care of. That the first term the power is diminishing and the second term the power is increasing. And also another important thing to notice, if you see, whatever is the power, the number of terms is just plus 1. So here the power was 0, so there is only one term. The power is 1, there are 2 terms. Power is 2, 3 terms. Power is 3, 4 terms, and so on. So you know, doesn't matter what, a plus b whole to the power n will always have n plus 1 terms. Fine. Now let us move to the idea of how these coefficients come. Now the coefficients of a binomial expansion, they are also called binomial coefficients, and all the binomial coefficients, if we just put together power after power, then whatever we get, that is called the Pascal's triangle. It is named after Blaise Pascal, the very same person who worked or who gave the famous idea about fluid dynamics, that the pressure at all different points exerted by a fluid is constant. Now, how this is happening, let me just explain. Now, this first one that you can see is basically when the power is 0. So when I am having a plus b whole to the power 0, then there was only one term, and that is 1. In the next case, it is a plus b to the power 1. So it was actually a plus b. So therefore, what was the coefficients? 1 and 1. Then if I go on writing all the coefficients like this, I get something like this, if you just go on checking. Now, instead of calculating a plus b whole to the power something and then finding what the coefficient is, you can see that we can directly find the coefficient from the previous one. How? All the ones on this side and this side will remain same. Only the numbers inside will change. And how this is changing? If you see that this one and this one, if you add, it gives you 2. This one and this 2, if you add, it gives you 3. This 2 and this one, if you add, this gives you 3. This one and this 3, if you add, it gives you 4. This 3 and this 3, if you add, it gives you 6. And again, this 3 and this one, if you add, it gives you 4. So therefore, just by adding the corresponding consecutive terms of the previous coefficients, I get the coefficient for the next one. So it is obvious that this 14641 is the coefficient for a plus b whole to the power 4. So therefore, you can write a plus b whole to the power 4. If I just want to write, how I can write? I can write it as a plus b whole to the power 4, that is equals to a to the power 4 plus 4 a cube b plus 6 a square b square plus 4 ab cube plus b to the power 4. So this is how the expansion of a plus b whole to the power 4 will look like. Fine. Now we need to give more general idea as to how these numbers come, because if I want a plus b whole to the power 10, are we going to solve this triangle till 10 stages? Obviously not. We are not going to do that, because that is also time consuming. So we need a formula which gives us the 10th stage of the triangle directly without calculating the previous ones. So now let us move to the next slide and see how these numbers come. Now, if you just look at this, what I have done, the first one is 0C0. Now 0C0, obviously 0C0 will be 1, 1C0 is again 1, 1C1 is 1, 2C0 is 1, 2C1 is 2, 2C2 is 1. So basically now, if you just look at all these, this is basically the Pascal's triangle, but all those coefficients which are there in the Pascal's triangle are actually nothing but they are the combination of the degrees, the various combination of the degrees of the binomial. So here, if I have a plus b whole to the power 0, so that is only one term, so 0C0. If I have a plus b whole to the power 1, so the power is 1, so I can have 1C0 and 1C1, so there are two terms. Then a plus b whole square, the degree is 2, so 2C0, 2C1, 2C2, so 1, 2 and 1. So like this it will go on. So now it becomes clear that if I have the power whatever I want, say for example 100 also, so I just need to find all possible combination of 100, and that will give me all the different coefficients or binomial coefficients for the expansion, right? So that's how we get all the different binomial coefficients for the expansion of the binomial terms. Now let us go and give a formal definition of what binomial expansion actually looks like. So for any positive integer n, a plus b whole to the power n will look something like this. It will start with nc0 a to the power n, nc1 a to the power n minus 1 into b, plus nc2 a to the power n minus 2 into b square, and so on. It will go up to ncn b to the power n, right? And this can be written in the condensed form, in the summation form, that is sum of r from 0 to n, ncr a to the power n minus r times b to the power r. Same way, a minus b whole to the power n, it will be alternate plus and minus sign. Why? Because as b is replaced by minus b, so all odd powers of b will have that negative sign. So that minus sign will continue till the last term, depending on what is the power. If power is even, the last term will be positive. If the power is odd, the last term is going to be negative. And this also can be condensed into summation of r equals to 0 to n minus 1 to the power r ncr a to the power n minus r times b to the power r. Now the same way, there are two special binomial expansions which can be written without writing so much. One is 1 plus x whole to the power n. Now as I have the first term as 1, so power of 1s doesn't make any sense, so we just do not write the power of 1, and so instead we can write it as nc0 plus nc1x, nc2x square, and so on till ncn x to the power n. And that, in short, we can write ncr x to the power r. Same with 1 minus, I should have written as 1 minus 1. This should be minus. So 1 minus x whole to the power n, so that is nc0 1 to the power n, and so on with alternate plus minus signs, and it will go till x to the power n, and if we want we can condense it down to minus 1 to the power r ncr times x to the power r. Fine. Now let us move to the problems. Now question number 1. In the first question we have find the number of terms in the expansion of 3x minus 7 by y square whole to the power 8. Now obviously the degree is 8, so therefore we know that this binomial will have 8 plus 1, 9 terms. So as simple as that. So there is nothing more to this problem. You just write this 8 plus 1, that's 9. But obviously in the next problem there is a little bit of work. You are given find the number of terms in 1 plus 2x plus x square whole to the power 7. Now this is not a binomial, this is a trinomial, but and also we don't know how to find the number of terms in case of trinomials. So we have to do something to this. Now you can see this 1 plus 2x plus x square is basically 1 plus x whole square. So 1 plus x whole square to the power 7, so that gives you 1 plus x to the power 14. So now this boils down to a binomial. Now once this boils down to a binomial, so this becomes 14 plus 1, 15 terms. Fine. Next. Same question. Now this time the only difference is that all the terms a minus b plus c, now they are different terms. There is no way you can reduce it down to a binomial. So when you can't reduce things down to binomial, then you have to work it in a different way. So what is the different way? So you consider this a minus b as d. So if I do so, then a minus b plus c whole to the power 6 is equals to d plus c whole to the power 6. But now let me tell you, this step is intermediate step which may not be required if you can work with a minus b as it is. If you are confused that how you are going to manage that a minus b, or say for minus b plus c, whatever way it is, clubbing two terms as one term, this is something which helps you to understand the problem better. You may not do that, you can do it directly as well. Now, once I have this d plus c whole to the power 6, now you know that this d plus c whole to the power 6 will have 7 terms, because obviously the power is 6, but this d will come in all different powers. So d, in the first term there will be d to the power 6, in the second term you will have d to the power 5, so on till the second last term where there will be a d. So therefore in all these terms you will have a binomial to the power something. So d is basically a minus b. So in the first term you will have a minus b whole to the power 6, in the second term you will have a minus b whole to the power 5, and so on. So now this a minus b whole to the power 6 in itself will give you 7 terms, a minus b whole to the power 5 will give you 6 terms, and so on. So therefore this expansion is going to give you 7 plus 6 plus 5, so on till 1, that is 21 different terms, right? If you don't understand, just try writing it down in your copy. That will give you the idea. Moving on to the next problem, number 4. Using binomial theorem, expand 2x plus 3y whole to the power 5. So you are just asked to do a routine expansion. So 2x plus 3y whole to the power 5, if I write in the condensed form, it is r equals to 0 to 5, 5cr, 2x to the power 5 minus r, 3y to the power r. So that how to write this, if I just expand it, so first r will be 0, so 5c0, 2x to the power 5, and 3y to the power 0 doesn't exist, so you need not write. Then 5c1, 2x to the power 4 into 3y, 5c2, 2x cube, 3y square, 5c3, 2x square, 3y cube, and so on till the last term, 5c5, 3y to the power 5. Now all you need to do is to go on computing all the values, multiply everything, and finally you will arrive to this answer. Fine. Just check it out for yourself, do the calculation once. Next, let us move to number 5, another expansion, similar one. So here you are doing x by 3 plus 1 by x whole to the power 5. So I'm just running through the problem. So again, if you write in the condensed form, it looks something like this. If you expand it, it looks like this with all the different terms. And if you compute the values and do your calculation, you get this. X to the power 5 by 243 plus 5x cubed by 21, 10x by 27, then 10 by 9x plus 5 by 3x cubed plus 1 by x to the power 5. Fine. So I think you get an idea of how to do this binomial expansion. A bit tedious work, but I'm sure it's not that difficult. So only thing you need to do is to be cool and calm and solve all these very carefully. You know, there are high chances of making mistake in doing these calculations. Now, number 6, using binomial theorem, find the value of 96 to the power 3. So 96 to the power 3 using binomial theorem. Otherwise in ISC you just have a calculator, you just press it there and you multiply, you get the answer. But that's not the idea of this problem. We have to use the binomial theorem to solve it. So this 96 to the power 3 can be written as 100 minus 4 whole cube, right? 96 cube can be written as 100 minus 4 whole cube. So basically the idea is to not make use of the calculator. So how you can do it without using the calculator. Now obviously you can directly do the multiplication of 96 into 96 into 96, but that calculation will become a bit bigger. So instead, this is a better way of doing it, because this calculation looks a little bit lengthier, but let me assure you, you can do this calculation faster than actually multiplying 96 3 times. And if the power goes higher, then this will be much better than direct multiplication. Now, obviously, 100 minus 4 whole cube, that is a binomial. If you expand, it looks something like this. And then if you just calculate the values, it will be this. And now then you are just doing some addition and subtraction, and that gives you the value, this 884736. Just check it once if it is actually 96 whole cube or not. I haven't checked, but I'm sure this is it. Now, number 7. Which number is larger, 1.1 to the power 10,000 or 1,000? Now, by the look, obviously, you can judge which one it is going to be, but still we have to solve it formally. Now, let us start off with 1.1 to the power 10,000, and that can be written as 1 plus 0.1 whole to the power 10,000. It's a binomial. Let's break it. Now, obviously, by the look of it, there is to the power 10,000, so there will be 10,001 terms. We are not going to write all of them, obviously, and we will be writing few terms which we require to write, at least all those few terms which we require to write. So to start off with, the first term will be 10,000 C0, then the next term will be 10,000 C1 into 0.1, then 10,000 C2 into, there is nothing here, into 0.1 whole square, and so on till the last term, 10,000 C10,000 into 0.1 to the power 10,000. So we don't require all these terms, we just require the first two terms, and that will be more than enough. So 10,000 C0 is basically 1, 10,000 C1 is 10,000 times 0.1 gives you 1,000, and then there will be other terms. I don't need to bother about the other terms because our work is done here itself. Now 1 plus 1,000 gives you 1,001, which is, and there are other terms as well. So therefore, the number is already greater than 1,001. So therefore, the number is easily greater than 1,000. And hence, I can say that 1.1 to the power 10,000 is a greater number than 1,000. Fine. Next problem. Number 8. Using binomial theorem, evaluate 2 plus root 3 whole to the power 7 plus 2 minus root 3 whole to the power 7. Now, obviously, we need to calculate both of them, but we are not going to calculate them individually. Now, let us start off with 2 plus root 3 whole to the power 7. So, 2 plus root 3 whole to the power 7, if you just see, it will be 7c0 into 2 to the power 7, then 7c1 into 2 to the power 6 into root 3, and so on till the last term. Now, you need to learn how to write them directly without writing all those coefficients and all. In this case, I haven't written. In some cases, you may need to write it. Anyway, now we are not going to calculate this. We are going to just leave it like this. Then, let us move to 2 minus root 3 whole to the power 7. 2 minus root 3 whole to the power 7 will be the same thing with alternate negative signs in between. Every second term will be having a negative sign. Now we are adding it up. So as we are adding it up, so all these second, fourth, 6th terms like this will be gone. So we will be left with only the odd terms where the power of 2 is odd. All those terms will be there and they will be added. So twice of that. So therefore, if you add them up, it will be 2 into 2 to the power 7 plus 21 into 2 to the power 5 into root 3 square, 35. Now 21 is actually 7c2. So you need to remember few of the combination values as well. So it will become easy instead of doing the calculation. 35 is 7c3. So no, rather 7c4. 7c4 and 7c3, they are same thing. Then 2 cube root 3 to the power 4. And then 7, that is 7c6 into 2 and root 3 to the power 6. So all these calculation, if you just go on doing, you get the value 10,084. So that's the answer. Right? Last problem. Using binomial theorem, prove that 2 to the power 3n minus 7n minus 1 is divisible by 49. Now, we did this kind of problem using mathematical induction, but we never did it using binomial theorem, and we'll see that using binomial theorem it becomes pretty easy actually. So to start off with 2 to the power 3n, so that can be written as 8 to the power n, and that also can be written as 1 plus 7 to the power n. Now this 1 plus 7 to the power n can be broken binomially, and using binomial theorem, if we break, then this becomes nc0 plus nc1 into 7, then nc2 7 square, and so on till 7 to the power n. Now what is nc0? That is 1. What is nc1? That is n. So the first two term will be 1 plus 7n, and nc2, that is n into n minus 1 by 2, and 7 square is 49. So all the terms starting from the third term onwards will definitely have a factor of 49. Why? Because 7 square, that is the least power of 7 that we can see. All the other terms will have higher power of 7. So if I take that 1 and 7n on the other side, so 8 to the power n minus 7n minus 1, that can be divided by 49 because all the terms have 49 as a common factor. So therefore it is a multiple of 49, so I can write it as 49m, where m is any natural number. Obviously it will be a natural number because we are working with combination and natural number at the end of the day, so everything is going to be natural. So that gives us the fact that 2 to the power 3n minus 7n minus 1 is divisible by 49. Fine. So that's it. That's the first class, introductory class of the chapter binomial theorem, and we'll come back with the second class with more properties and more fun. So as always, if you have any doubt, please get it clarified. Thank you.